Hello, my BC laddies. Here we go with another one. This is 2010 BC, question number 4. We skipped 3 because 3 was on parametric equations, and hopefully you got my Google Classroom notice that you will not be tested on parametrics or polar. I'm sure there was a great cheer when you heard that. But they will be grading parts of the series, not everything. So we'll continue to do the series problems. It's limited, but that's what's going on. So here is number 4. So we want the area of R. Let's see. This function here is 2 radical x, and this is y equals 6. So we're going to be adding rectangles. And to show you what color, the yellow ones. So we're adding rectangles. There's the first one. There's another one here. And they're going all the way across. The last one, whoa! The last one being, I don't know why it exploded. Whoa! What's going on? It just got really large. Okay, the last one being right there. So how do we add those up? Integrating. Integrating is adding up a bunch of things. So we're going to start at 0, and we're going to add up the rectangles. The last one shall be at 9. And basically, we're adding up areas. But what is the area of a rectangle? Let's take a look at one of these. Let's do red. We have the height of the rectangle there. And if you look at the width, that is a change in x. That's a dx. So the area is height times width, but our height, okay, what is h? H is big Y minus small y, and y is bigger up top. So big Y is here, small y is here. So you take the bigger minus the smaller. So that's going to be 6 minus 2 radical x. So I am going to place all of that in here, 6 minus 2 radical x, and the width is dx. And now I need to calculate this. Antiderivative of 6 is 6x. This is x to the 1/2 here. So let me side note that. So it's going to be x to the 3/2. So x to the 3/2 divided by 3/2, which is times 2/3. And we're evaluating from 0 to 9. We're running out of room. I'll put it down here. So we get 6x minus 4x to the 3/2 over 3. Plug in 9 first. And when we plug in 0, it's all just going to be 0. So we get 54 minus. So here, we're going to do the square root first, then cube it. And the square root of 9 is 3. 3 cubed is 27. So we have 4 times 27 over 3, which is 54 minus 4 times 9. 54 minus 36. Is that 18? Could it be? Let me look at my answer. Wow, I know how to algebra. All right, part A, we're done. Let's go to part B. I'm gonna erase all this stuff because it's in my way. Part B, what's it asking for? Do not evaluate. I like that. an integral expression. I like that. Volume, solid. So you're rotating around the line y equals 7. Let me do some magic here. Watch this. Bam. Whoa. Where did that border come from? Let's get rid of the border. No border. There we go. Magically, we have space. So we're going to rotate it around the line y equals 7. So that's going to be right here. So you should realize, oh, I can make ovals. Coolio. We're going to have big ovals and small ovals. So as the outside's rotated, you like that, huh? You're going to get that. I can make those wider. And then these, whoa, give me smaller ovals. That's pretty cool. So we're going to find the volume of the green part. And as you can see, when the inner line, when this line is rotated, this part's going to be hollow because this region is the part that's rotating and producing actual area. But when you rotate this line, there's nothing inside, so we're going to subtract that. So to stay consistent, I'm going to make this green. Now, how do you get volumes? Volumes is area times thickness. So area times thickness. And then we need to subtract. Oh no, I don't have the yellow. See, is it that color? I think that's it. Minus, pretty good. The integral. And again, it's the area times the thickness of the yellow. And that's from 0 to 9. And this is 0 to 9. But what's the area of a circle? Clearly, that's pi r squared. So that's r for the big circle. That's r for the little circle. So should we call that R1 and R2? Let's do that. Let's call this R1, and this one is R2. And let's see. So R1, it's big Y minus small y. Big Y is that red line, 6. Not 6, that's 7. I should label that so we know what it is. This line is y equals 7. So R1, right here, is going to be big Y, which is 7, minus little y, which is 2 radical x. So let me fix this. 7 minus 2 radical x. And then R2, it's going to be the bigger y, which is 7, minus the little y, which is 6. So 7 minus 6, which is 1. So that's the radii of the two circles. And now we're pretty much done. So the volume is going to be the integral from 0 to 9 pi, you can put the pi outside, r squared. So my r is 7 minus 2 radical x squared. The thickness is dx minus pi, again, you put it outside the integral. R, it's going to be just 1 squared dx. Now that second integral, you don't even need it. It's just a cylinder. So it's pi r squared from 0 to 9. So you can leave it or take it or leave it. But that's the answer. We are finito with that. I'm really digging using this notes app. I think the pictures are kind of easier to see than when I freehand it. All right. Part C. Let's look at that. So R is the base of our solid. So that's like the floor of our building. So that region is the floor of our building. Let's get rid of some of this stuff we don't need. I don't need that, or that, or that, or these circles. And let's get rid of all this stuff. All right, and this was y equals 6. So, region R is the floor of a building. Kind of a weird shaped building. Most buildings are more square or rectangular, but that'd be kind of a cool room. So that's the floor. And on this floor, you're building rectangles on top. And it's going to be kind of weird to write this, but we are going perpendicular to the y-axis. So I'm going to take one slice. If you were to slice this building, can I do this? Oh, I can't do slanted rectangles. I'm sad. I'm going to have to freehand this. But I think I can do lines. So here's one slice of the building from here to here. That's the base. And it's going to come up off the floor. So this comes out off the floor and across and up. I don't know if you can see that, but ooh, that's ugly. Oh, whoa, 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 whoa. Let's delete that. Let's choose that. I'm going to reshape it. Oh, it's snapping. I should disable that. I don't know if you can see that, but that's a slice where this is sitting on the floor of my building, and these are the walls of the building coming up off the page, and this is the roof of my building. And so I'm going to have these shapes, the first one starting here, and the last one across there. So we have these rectangles starting here, ending here. And so part C, you want the volume. Volume is the area of the shape times the thickness of the shape. And we're going to add them up. This time, we're starting at 0. And since we're going up, we stop at y equals 6. So our limits will be 0 to 6. Now, we have rectangles. So the area of a rectangle, I'm going to call it length times width. And the thickness, let me see if I can do this justice. The thickness of this slice, ooh, I like that, is going to be a change in y. I really like that. Pretty cool. I like it a lot. Do you like that? So that's going to be dy. So length and width, actually let's do base times height. I think that'll make sense, but that h was used before. We'll do it length and width. So we'll call this the length of the rectangle, and that's the width. You can switch those if you want. It doesn't matter. So L is going to be the bigger value of x minus the smaller value of x. G. So that line right there, x is bigger to the right. that's big X. And an X over here, that's small x. So as you move left and right, X changes, not Y. So to get this distance, you need the value of X here minus the value of X here. So we need to divide both sides by 2 and then square both sides. This is the value of X, big X. And the value of X right here on this line, X is 0, 0. So big X will be Y over 2 squared. Small x will be 0. That's the length. Now, how tall is our building? Let's see. I think we have it here. The height is 3 times the length of the base. So the height, which we call W, is 3 times the length of the base, which is 3 times y over 2 squared, which is 3y squared over 4, which is y squared over 4. So now we're ready to do this. Integral from 0 to 6, the area is length times width, so y squared over 4 times 3 y squared over 4 dy. And I love this part, write, but do not evaluate. I am done. I am completo. Bam, watch this. Oh, no, I don't want that. Okay, let me change that. Fill, no fill. Let's try that again. Bam! There is our answer. Beautiful. Hope you all are happy with that. They simplified that to 3y to the 4th over 16, but we don't have to do that. We are good. I hope you like that problem. I like it a lot. And that's it for number 4.